Hello everyone, I am Aman, coordinator of Programming Club. Today we'll be taking a session on brute force and greedy. Uh, I, along with Anmol, will be discussing these topics today. So, brute force and greedy are basically two different approaches to solve a problem. So, I'll first start. Before I start, can someone confirm if I'm audible and my screen is visible?
Yep, I mean.
Okay. So I'll start. I'll start with the brute force approach. So brute force is basically an approach where you go through all the possible solutions to a problem and then find the best among them. So it's uh, it's one of the more simpler ways to solve because you don't have to think much. You basically do try all the possibilities and then find the best among them. But because of this, it may take a lot of time. So you may get time limit exceeded for some problems if you're not careful. So you have to keep this in mind. So we'll try to understand brute force with the help of an example. So this is our first example. We have an array and we have to find the minimum sum that we can obtain by adding two elements of the array. So say our array is this A 25163 and we have to find the minimum sum that can be obtained by adding any two elements of this array. So we use brute force approach to solve this. So what we do is basically we find all the possible pairs and then find their sum and then choose the minimum sum that we can find. So these are all the possible sums that we can obtain. And here we can see this sum 2 plus 1 equal to 3 is the minimum. So our answer would be 2 and 1. These are the two elements that will give us the minimum sum. So what we did basically was find all the possible sums and then choose the minimum from them. So we have one more example. So in this, we have a person who starts at place city A and he has to visit four cities B, C, D, and E, and he can visit them in any order. And the flight cost of the travel cost between any two cities is given in the diagram. So what we have to do is we have to find the minimum cost that traveler has to pay in order to visit all the four cities and then return back to his home at A. So again, in this, we apply a brute force approach. What we do is we list down all the possibilities, all the possible routes the man can take. So these are 12 of them. Uh, the routes that the man can take, and there will be 12 more which are not mentioned here, but they are basically the mirror images. Basically, what that means is A, B, C, D, E, A, and then the mirror image of that will be A, E, D, C, B, A. So it's basically the same. The cost will be the same because we are taking the same path in the reverse order. So the cost still remains the same. So here we listed all the possibilities, all the possible routes the man can take, and then we choose the minimum from them. So we see the 11th one, 676 is the minimum cost. So that is the optimal route for the man. So that will be the route he should take to get to pay the minimum amount of money. So is this example clear and the previous one? Any doubts? Fine. So I'll move ahead. So this was basically the idea of brute force, what we actually do in this method. And now we'll see how to implement brute force in our codes. So brute force basically is trying out all the possible options. So what we do is usually what we'll do in these cases is that we iterate through a loop, okay, which starts from a lower limit to a higher limit, which basically checks all the possible options. So we'll try to understand this with the help of a few examples. Okay, so these are some problems I've selected. Let's have a look at them. Okay, this is the first example. Uh, I'll give a minute for you guys to read this. Okay. So in this problem, basically, uh, we have an input, a year number, and then what we have to do is we have to find the minimum year number, which is strictly larger than the number given to us, and that year should have all digits distinct. So can anyone think of a method to solve this problem using a brute force approach? Basically, you try out various different possibilities and then find the best. Anyone?
Yeah, I guess I mean maybe we can give them some more time, like a couple
Okay,
of minutes, so they can think through the
sure, sure.
problem.
We can keep adding one to the given year and then check whether the number of the digits in that they are equal or not, and keep on doing it until we get that all four digits are different.
Yeah, correct. So basically, we start from the year. Let's say the year given to us is uh, say it's 2008. So since the answer has to be strictly greater than it, so we start checking from 2009, and we see that it has these two digits are same. So this can't be the answer. So we move on to the next year, 2010. We can see that it has two equal digits. So even this can't be the answer. So we move on to the next year. It has two ones. So again, next, these are same. And then we end up with 2013. And we can see that it has all the digits distinct. So this is our approach. We list down all the possibilities after 2008 and then check which one of them satisfies the condition. And then we output that year. So we can quickly have a look at the code. So this is what I've written. We take the year number as input, and then we start from year I equal to n plus 1. And then what we do is we keep a frequency array which stores the number of occurrences of every digit from 0 to 9. And then we run a while loop. So just to add the frequencies, the number of times they appear. So say our year is this 2009. So now this frequency of y percent 10, so that is 9, it gets incremented. Initially everything is 0, it gets incremented by 1, and then we do uh, y divided by equal to 10, which means now our y is 200, and do now our y becomes 200, and then we do y percent 10, which is 0, and frequency of 0 gets incremented by 1. And then we again do the same thing. We reach 20, we do y percent 10 is 0, and then the frequency of 0 gets incremented by 1. And then what we check is we basically iterate through the frequency array and check if any of the frequency is getting greater than 1. If that is so, we change our flag variable I have declared, which is initially 1. So if any of the digits frequency becomes greater than 1, then I do flag equal to 0 and break out of the loop. And we know that this can't be the answer. So what we do is we again go to the next year, to the for loop. And now our year becomes 2010. And we basically keep doing this. And when we reach 2013, frequency of all the digits will be 1 or less than 1, which basically means for 0 it will be 1, 1, 2 and 3 it will be 1, and 4 onwards it will be 0 in the frequency array. So this is allowed. So that's why our flag remains 1, it doesn't become 0, and then we output that here and break out of the loop. So this is our greedy approach to solve this problem. So does anyone have a doubt with this?
No.
Okay. So I'll move
So
on to the next.
essentially, we are adding one and then checking, right?
Yeah, we are adding 1 to the year. I keep
But
adding 1 to the year, and for every year that I get, I check if the digits are distinct. If they are distinct, then that will be my answer. I print that and break out. If that is not distinct, then I go to the next year and then check for that year. And then I keep doing this until I find the answer.
yeah, but let's say we are going from 1987 to 1988. Now,
Hmm.
in this case, the ones digit and the tens digit, they are the same. So let's say we add one to the ones digit, and then we find 1989, and then again do it and find 1990. Now, going from 1990 to 1991 is a waste of time because the repetition has already happened in the tens digit and hundreds digit. So 1991 to 1999 is not needed. We should directly move to 2000, right?
Yeah, that is correct. See, but what we are using is, see, yeah, our year goes from 1000 to 900, and our loop will break. So the thing is, in brute force, we don't have to think much. We just try out everything. So since the time limit won't get exceeded, we can see that the input size is small. So what we can do is we can just check for everything. You're correct that we don't need to check from 1990 to 2000, but then because we don't have to think much in this approach, so we just check for every one of them. Because
Oh,
if you have to say, if you want to skip from numbers from 1990 to 2000, you can also do that, but like it will become a bit complicated because you keep doing this for say 1999 to 1990 to 1999, and then again from 2000 to 2009. So you have to manually add these cases, and then your code gets complicated. Instead, what we can do is we just don't think about all that. We just check all the possible options. Like we iterate from
you
the.
don't really have to manually do it. Like, let's say the hundreds digit and the tens digit, these are same. Then add one to the tens digit, right?
Sure, you can do that. That is fine. But in this approach, like that is what you're saying is correct. But in this approach, we don't need to do that because see, the input size is very small, and then what will happen is our time complexity will be at max O of say around 10 power 4. So it will still pass, right? Because 2 seconds is the time limit. So it's fine. We can do what you said, but we can also check for every year.
Yeah, I was just, I mean, clarifying it. You don't need to do the manual thing, right? The lower value position, add one to it. That's it.
Yeah, fine. You can do that. That's correct.
Yeah. Okay.
Any other uh, queries about this example? No. So we'll move on to the next one. Okay. So in this example, in this question, I'll give some time for you guys to read this. Okay, so I'll explain the problem first. So, so what we are doing in this example is we have a ribbon. Say this is our ribbon. It is of length n. What we have to do is we have to cut this into some pieces, and every piece should have yeah, and every piece should have length either A, B, or C. So we can cut it something like this. This is, or maybe uh, this is also fine, all A. So what we have to do is when we cut it into a number of pieces, each having length A, B, or C, we have to find the maximum number of pieces that can be obtained. So we have to cut it in such a way that we maximize the number of pieces. So I'll give you guys some time to think, and if anyone can think of a brute force approach to solve this problem, you can unmute and answer. Any questions in the any doubts in the question? Is it clear?
So basically, it is like if the ribbon is of length n, so like if we can get x pieces of A, y pieces of B, and z pieces of C, so xa plus yb plus zc should be equal to n. And in this case, we are asked to find like whether like the maximum value of x plus y plus z, right?
Yeah, that's correct. That's basically the problem.
Okay.
So what we could do is first find number of A size ribbons from 0 to iterate loop it from 0 to n by a. Can you hear me?
Yeah, I can hear you.
Yeah. 0 like, 0 to n by a, and then in the second loop for v size b strings from 0 to n by b minus the na. And then for C, we can just subtract n minus the na plus nb. So we can iterate through na and nb, iterate na and nb, and for C, we can put the remainder and find the maximum of na plus nb plus nc.
Yeah, that's correct. So what we do is, I'll just go through the problem again. So we have to find x, y, z such that xa plus yb plus zc equal to n, and we have to maximize x plus y plus z. So in this, what he said is, we iterate. So what we can observe here is, uh, x is equal to n minus yb minus zc by a. And we know that all of these are positive numbers, y, b, z, c, and a, positive integers. So what we can say is x lies between 0 and n by a. Is this fine? Because we subtract yb and zc from n and then divide them by a. So x can the value of x can be at most n by a, and similarly y can be from n by b, and z can be from n by c. Any doubts in this? Fine. So what we can do is here is one approach to solve this. So what we can do is we check all the possibilities of x. So since x lies between 0 and n by a, we check all values of x. Here I represent x with I. So for all values of x between 0 and n by a, we check all values of y and all values of z. And if this condition, our initial condition, the problem's condition is satisfied, then that is a possible solution, ijk, that is a possible solution to our question. And then we check if it is greater than maximum. If it is, then that becomes our new maximum. So any doubt in this approach? We basically try all the possibilities, all the possible values x, y, and z can attain, and then check if that set of values satisfies this. If it does, then uh, our answer will be the maximum of the previous answer and I plus j plus k, which is this x plus y plus z. So this is our approach, brute force approach in this. Uh, is this approach clear?
Yes.
Okay, but there is a small issue with this code. Like, just look at the constraints one. Can anyone tell me what the issue with this is? The
It's like O of
constraints,
n cubed.
yeah,
Clearly, maybe
yeah. So basically, what is happening is uh, our n, a, b, and c lie between 1 and 4000, and our loops go from 0 to n by a, 0 to n by b, 0 to n by c. So the time complexity of our problem becomes this O of n cube by a, b, c. And then a, b, and c. So in the worst case, what it can happen is n becomes 4000, a, b, c are 1. So that will give us O of this 4000 cube. And we know that 4000 cube is 64 into 10 power 9. But we know that our computer can perform 10 raised to 8 operations at max in a second, but this is exceeding that. So this code will give time limit exceeded. So, so can anyone think of how to, optimize this code a bit so that we can do it within the time limit?
The third one doesn't need a for loop because it will be the not remainder, leftover after subtracting it from uh, n n minus x into a uh, minus x in y into b whole divided by c.
Yeah, correct. So what he's saying basically, when we choose I and j already, then we don't have to iterate through the last loop. What we can do is when x and y are decided, then our this z becomes fixed. So 1 second. So yeah, this is our original equation. So our z into c is n minus xa minus yb. So we don't need the last for loop because we know that z will be equal to n minus xa minus yb by c. So we just have to check, since z has to be a positive integer, we just have to check if c divides this number. Uh, if c divides this number, if it does, then we have a solution to our question, and then we can check for that. So basically what we do here is we don't need this last loop. What we do is if n minus I into a minus j into b percent c equal to 0, which basically means c divides this number. So z is an integer. So if we have a z that is an integer, then that is a possible solution to our question. And then what we do is we our z becomes our k. So let's say int k, it is n minus I into a minus j into b divided by c. So this is our z, and then we can just do answer equal to max of uh, I plus j plus k. So what we have done here basically is we have removed one for loop. So now our time complexity becomes O of n square by AB. And now what we see is from the constraints, what we can see is n is from, so in the worst case, it will take n square by AB's value will be 4000 square, which is 16 into 10 power 6, which is less than 10 power 8. So this solution will pass because it is less than 1 second. It will take less than 1 second time. So the original the first method that we used will give time limit exceeded because it is taking 64 into 10 power 9 operations in the worst possible case. But after we optimize our code to remove the last loop, it's taking at max these many operations, which is less than 10 power 8. So the code will pass because it is less. It will take less than 1 second. So any doubts in this second approach that we have used?
But just one small doubt, like what if this thing, the n minus I into m minus j into b, if divided by c, if it's not an integer, but then it ends up getting converted into one because of like k is declared as an int variable.
No, so we first already checked if C divides this
Oh,
number,
okay.
right?
Yeah,
So when
understood.
we do this division, we are assured that K will exactly be this value.
Understood.
Okay. One more thing we have to check in this problem is that uh, this thing, what we call it, K, this can also become negative when we are subtracting. So n minus I into A minus j into B can also become negative. So we have to put one more condition over here. A minus K into B greater than equal to 0. So we have to check this condition as well. Earlier we didn't have to check because our third loop was iterating from 0 to n by c. So we were assured that it would be a positive number. But now that we are subtracting I into A and j into B from n, so there is a case that this might become negative, but we know that k can't be negative. So we just check once if this is greater than 0, only then we enter inside the if statement and we perform these operations. So is this clear? Okay, so I'll take that as a yes. So uh, okay, so we can move ahead to the next problem. Just once more, I'm asking if there's any doubts, you can feel free to ask or ask in the chat also.
No doubts.
Okay, so we'll move ahead to the next one. Uh, this is another example. I'll give you guys some time to read this. Uh, okay, so I'll explain the problem. So in this problem, what we have been given is a list of zeros and ones. So problem second. Yeah. So here we have a list of zeros and ones. So we'll take the example case here. 1 0 0 1 0. And what we can do is choose two indices, I and j, any two of these. And then what we do is flip all the numbers that lie between I and j. Uh, like flip, if it's 0, then we change it to 1. If it's 1, we change it to 0. So we do this, and we can do this for any I and j we choose. So for example, we choose these two. So our new string becomes this 1 1 1 1 0. And may say if we choose uh, these two, our new string becomes 1 0 1 0 0. So we can do this move exactly once we have to do it, and then what we have to do is maximize the number of ones we can obtain in the new string after doing this operation. So this is our problem. So I'll give you some time to think. If anyone comes up with a brute force approach to solve this problem, they can unmute and answer. So first we see is that value of n is at most 100. So we can have, say, O of n square n cube type solutions because it will still be less than 1 second. So first we check that. So it gives us an idea that, okay, we can apply brute force now. So if anyone has an idea, then please feel free to answer.
We can loop through I and j, like I from 0 to n, and then j from I to n, and then count the number of ones in between ith and the eighth position and jth position, and then find the max, or no, find the number of zeros, and then um, one with maximum zeros will be answer. We should also minus subtract if we find ones, like plus one if it's zero, and minus one it's one.
Yeah. Okay. So your approach is correct. So uh, if you guys want some more time to think about it, I'll give some more time. And then I'll start with the explanation.
Basically, it's like if we assume that we flip off everything, every number in this array, and then like we have to calculate like the maximum sum of like in that.
Yeah, yeah. That's the same as the number of ones. The sum will be, yeah,
Yes,
it's the same thing.
understood.
And just note that the operation you perform has to be on a continuous substring. So like this. So you can only do on, say, something like this or this. Okay, you you can't flip this 0 and this 0 separately and then this 0. That's not allowed. You have to do the operation on a this thing, on a continuous substring. Uh, okay. So I'll start with the explanation. So what we do is, so I'll take this example again. So what we do is, we have to choose two indices, right? I and j. So what we can do is, we can choose all possible indices, I comma j, all the possible pairs, and then flip the values between them, and then find the sum, and then find the number of ones. So, okay, so I'll just go through the code once. Okay, so we first find the number of ones and zeros initially. Okay, so this is our we input n and declare an array and then take it as input. And then if the value is 0, we do zeros plus plus and ones plus plus. In the end, we get the number of zeros and ones in the original array. Now what we do is we brute force through every possible I and j that we can have, every possible pair. So what we do is we start I from 0 and it goes to n, and for that I we choose any j from I to n. So what we do is we first start I equal to 0. So we choose this one, and then our j goes from I to n. So our j can be, first our j will be 1 itself, which means we just flip this. And then our j is 0. So we flip 1 and 0. So this becomes 0, 1. And then our j is 2. So these are our I and j now. And we flip this substring. And then we keep doing this for all j possible for I equal to 0. And then we check for the next I. So then we go to this one, and then we check j from this, and then we flip this, and then we check. So basically what we are doing is we are trying out all possible I and I comma j pairs that we can have. So I'll go to the code again. Okay, so this is the code. So we start, we find all possible I comma j pairs, and then after we have decided what, say we chose these two in a particular case. Now we check the number of zeros and ones in these. So say we chose this. This is our just giving an example. So for this, what we do is we count the number of zeros in this substring. So what we do is we loop through I till j, and then we find the number of zeros and ones present in this. And then basically what will happen after flipping is the zeros become 1 and the ones become 0. So, okay, so what we did is we first counted the number of zeros and the number of ones. And then, what we did is then the new number of ones will become this. We subtract the number of ones in this substring and add the number of zeros, because basically they get flipped. So the ones originally that we had in our array, and then the ones we find in this. So we subtract the ones we found in this because they become 0 after flipping, and the zeros will get added. So now our answer becomes the maximum of answer and this number, which is our new number of ones in the array after flipping. So we keep doing this for all ij pairs, and then we finally output the answer we get. So this is basically what we did. This is a brute force approach to solve this problem. And we can check time complexity in this. the worst case time complexity will be O of n cube. So O of n cube will be the worst case time complexity, but n cube will be at max 10 power 6. So which is less than 10 power 8. So that's fine. It will pass within the time limit. So any doubts in this? Can unmute or ask in the chat. Okay, so I'll take that as no doubts. So basically these were 3 problems on brute force. We'll give you guys more problems in the problem set. You can try it on your own. And maybe if you want, you can try these codes yourself also later. So I'll just end my part with this final remark that does brute force work every time? So in many cases, what will happen is brute force will give time limit exceeded, because if say our n is 10 power 5, so O of n square will be 10 power 10, which is greater than 10 power 8. So it won't work. So brute force will not work every time. Sometimes what we'll have to do is maybe optimize our code a bit, just like we saw in the cut ribbon problem, this one, that O of n cube solution was giving time limit exceeded because it was 64 into 10 power 9. So that was more than 10 power 8. So what we have to make sure before we start the brute force method, if that is possible, so only if it is possible, we go for that approach. Otherwise, we may have to think of other methods like maybe optimization or some other idea. So this is one thing you have to make sure before you apply brute force to any problem. So any doubts on brute force? Any of the problems or the concept, anything? Fine. So that was my part. Thank you for attending. In case you have doubts, you can ask us later, and I'll hand it over to Anmol if he's ready. Anmol?
Yeah, we can take a 5 minute break now. It's already been one
Yeah,
hour.
sure. We'll take a break and then Anmol will take the next part. Thank you for attending this part. Bye bye.
We can start the next part at 3:17. Till then, we can take a break of 5-6 minutes.
Yeah, and if you guys have anything that you want to ask now, you can do that as well to either Anmol or Ayman about their topics. So yeah, feel free to do that now as well.
Yeah, so we can start now, I guess. So hello guys, I'm Anmol Panda from the Programming Club of IIT Madras. So today we are gonna discuss the topic of greedy. Now, before I start, I just like to mention a point that whenever you're getting any doubts, feel free to speak them, either preferably unmute so that the session becomes more interactive, or you can put them in the chat also. Like, see, the main point of the session is, just me coming here and writing some code and going. It's about you understanding what's happening in the session and being able to apply that. So feel free to ask your doubts anytime. Don't be like nobody is asking anything, so I'll not ask. Uh, you can start the chain. So yeah, with that said, let's get started. So is my screen visible? Can someone confirm?
Yeah, it's visible.
Yeah, cool. Okay. So today we are gonna discuss about greedy approach. Now, if nobody has heard the name, then it might sound a little bit weird. The word greedy, but the approach is what it just says. So a greedy algorithm is an approach for solving a problem by selecting the best option available at the moment. Basically, what happens is in a problem, you try to approach the problem step by step. So in a greedy approach, what you do is at every step, you see whatever is the most optimal thing at that step of time. Like you don't care what has happened in the past, what will happen in the future. Whatever looks the most optimal thing presently, you do that thing. And you keep doing this until the end. So that is basically what a greedy approach is. A greedy algorithm doesn't worry whether the current best result will bring the overall optimal result. So you just do whatever is best for you now. You don't care about whether that is going to finally give you the right answer or wrong answer, or even if whatever you did now was wrong, you would not go back and correct your decision. You will just do whatever is the most, most feasible or most optimal thing right now. So whenever you're using a greedy approach, what you're doing is at the present instant, you're trying to find what is the best thing for you. But after solving the problem, you're also supposed to ensure that the final solution you have obtained by doing the steps is also the best solution globally. That is, it's the best solution to the entire problem. So yeah, that is what a greedy approach is. Now, you might not have understood the theory of greedy. That is completely fine. There's no fun in just doing tons of theory without problems. So we'll solve some problems. So we'll start with an example. So you can see this question and maybe take 1 or 2 minutes time to read it, and uh, if any of you get any approaches, you can either unmute or speak out. Basically, you need to tell what items you're supposed to add in the box. Is the problem clear
So
to everyone?
in this case, like we can take all the items and then arrange them in like a descending order of their costs, the values, right?
Yeah, that's it. So it's basically it's like you have n items. You have to keep. You have to make a box which has n items, and you need to maximize the value of that box. So what you do is at every point of time, you take the maximum value and you put it inside. You take the maximum value and you put it inside. You keep doing that for m items, and you'll always have enough items because the constraint has been given m greater than equal to n. It's like say you have been given m gifts. You need to take n gifts among those. So you'll obviously take those ones which are like the most expensive ones. So kind of that thing only. So you keep adding items. You take the currently whatever is the maximum item available in the set, you take that and you put it. So that is what this approach is, and this is what we call greedy. At every point of time, you're taking the maximum item and you're putting it inside your box. You don't care whether ultimately they'll give you the answer or not, but in this case it does give the answer. So that is what a greedy approach is. So this is just a starter example. So we can go ahead to some code forces problems now. So how it would go is I'll show you the problem. You read it for and try it for say 4 to 5 minutes, then we can discuss the problem. This problem is actually slightly big. It won't fit in the screen. What you could go is you could just Google force segments code forces, or you could just put this thing 1468E code forces. You would get it something like this 1468E code forces. And the first problem is what you would get. So you could see it in your devices also. Either way, I'll just put it here. So I'll give it 4 to 5 minutes time. Maybe at 26 or 27, we can discuss the problem. And also, if any of you get a solution within this time, I would request you to be silent for some time so that people can try it unbiasedly. And after 4 to 5 minutes, we can discuss all the approaches. Meanwhile, if you have any doubts in the problem statement or anything which was taught earlier, you could ask that thing. Any doubts in the chat? Yeah, cool. So yeah, is the problem statement clear to everyone first? I would
Yep.
explain that once. Yeah. So basically, you have been given 4 rods, and you need to make a rectangle using them. and you need to maximize this area of the rectangle. So anybody thought of anything till now? Any approach or whatever?
It's like almost the first two, like if we take these four lengths and we end up sorting them in terms of their values.
Yeah.
So the
Yeah.
first two smallest ones, they are kept on the opposite sides, and the next two are kept on the other opposite sides.
Yeah. Okay. Right. That's right. How would you find the area of the rectangle in that case?
That gives like the minimum of the first two into the minimum of the last two.
Yeah. That's correct. So I would explain what he just meant now. So what you're supposed to do is you have been given four lengths, and you're supposed to use these lengths to make a rectangle. So what you do is, suppose your situation is something like this, that you don't use any of the lengths to the fullest. Now you're actually wasting a lot of area. The reason is that what you could do is you could just extend this thing. You could just maybe extend this one above. So something like this, and you could extend this one above. So whatever is the minimum among these both, you can take that as a side, and the similar goes for the other opposite sides also. So say your sides are A, B, C, D. So what area of the rectangle you could get is, uh, two of these sides will be opposite. Say any two. For now, any two will come out to know which is the optimal. Say A and C are opposite. So the maximum side you can put in the rectangle would be minimum of A comma C. And similarly for the other opposite pair too. In this case, it'll be B comma D. So the other side will be minimum of B comma D. Is this point clear to everyone? Any doubts in this? Or anything in the chat? Okay. Yeah. So I take that as no doubts. So what you do is, the two opposite sides. Basically, if your two opposite sides are say A and C, it will be minimum of A comma C into minimum of B comma D. That would be your answer. Now you need to maximize this thing. So for getting the maximum area, you would always want, to get the maximum sides as these two as the product. So if you could get the product of C and D, then it would be really nice. But is that possible? We need to see. Now, suppose A, B, C, D are in sorted order. Like I've sorted the things such that A is the smallest and D is the biggest. So can I use D ever in, when I take minimum of two things, can the value be equal to D? Suppose everything is distinct.
No.
It cannot be equal to D because D is the biggest value. So can it be equal to C? So we'll go to the next smaller one. Can it be equal to C if I take pair of two things?
Maybe. Like if C and D, then
Yeah,
yes.
you can take C and D and the minimum will be equal to C out here. So we are able to do C out here. And if C and D you're taking as a pair, then you have to take A and B as a pair. In that case, the minimum would be A here and A and C here. But now, can we do any better? So we can get C as the minimum only in this case, that when we take C and D as one pair. Because if we take C's pair with anything else, since this is in a sorted order, C is greater than A and C is greater than B. So C will never come as the in the product. So that would be less beneficial for us. So we would want C to be in the product because it is one of the higher values. So it turns out that this will be our optimal arrangement, that you take the two smaller things A and B, then you take the two bigger things C and D and you keep them. And what you do is you take the side which will come from these two C and D will be minimum of C comma D, which is C, and the side from A and B will be minimum of A comma B, which is A. So we can just code that up once and just submit it. Just a minute. Just remove all this.
If you don't mind, can you say what ID you are using?
I'm using Sublime Text. Using Sublime Text, I'll be putting the input out here and I'll get the output out here.
Okay, thank you.
Yeah. So here in the input, you have to take t test cases first and you have to take 4 integers as input. So I'll take the test cases first. Take int t, c and t. I'll run the loop for t test cases. You can either do a for loop also for int I equals 0, I less than t, I plus plus. Or this is also another way you can run a loop for t times. Now this is, I prefer this because you don't have to use an extra variable out here. So I need to take 4 variables. So I'll just take them in an array. I'll take input. Now what I need to do is whatever discussion we have done that on the sorted array. So we can sort the array with the inbuilt function sort a comma a plus 4. Now we know that the answer is minimum of a comma b, which will be a, that will be the first element, that will be a of 0, into minimum of c comma d, which will be the second element, sorry, the third element, that is c. So the third element would be denoted by a of 2. This is the thing. We can run the samples, copy the input, put it out here. Can run it. So the 325, 2000, and that is the input here. So let's try submitting it. Okay, how do I remove this thing? Just a minute. Yeah. So submit this thing. Now I'll give this code to you. I'll attach them in the slides. Yeah, it's accepted. So, and you see the time complexity also of this thing. That'll be O of 4 into t, and they have given t of the order of 10 power 4. So that'll be of the order of 10 power 5, which is accepted. So that was the first problem. Now, any doubts in this problem? Any doubts understanding the problem statement, or you want me to repeat the solution again? You can put your doubts in the chat also. I'll show the problem here. Any doubt in this problem? If not, we can move ahead to the next problem. Okay, okay, so I take that as no doubt. So yeah, we could move ahead to the next problem. I'll attach this code, this submission out here, so you can see it for future references. But I would strongly recommend you to code by your own also. That's the reason I'm coding it here in front of you also. So you can go to the second problem. I'll put this thing in the Meet chat. Yeah, so I've put it in the Meet chat. So again, you can take some time to see this, read this problem, probably 3 to 4 minutes, and then we can discuss the problem. Meanwhile, if you have any doubt in this problem or any of the previous things, whatever you have discussed, you could ask that thing. We would maybe start at something at 39 or something. Anybody speaking anything? If yes, your voice is breaking. So yeah, is the problem statement clear?
Yeah.
Doubts in the problem statement. Okay. Uh, so in the problem, basically what you have been given is that you have n blocks. Yeah, basically n buildings you can say of varying heights. So and you can perform one operation. What they have defined is you take a block from one building and you put it on other building. Say you're taking this and putting it here. So you can do any number of operations like this, and you have to minimize the height difference between the tallest and shortest buildings. Basically, you're trying to make all the buildings as equally tall as possible. If maybe all the buildings are equal, then that is like the ideal case. Max minus min is 0 because everything is equal. So you can take any number of operations. You need to find what is the minimum possible value of this. So yeah, anybody got any approach to do this?
So basically, this is like trying to see like if there's an average of the given array and whether that average is like an integer or not.
Yeah. So what would you do in either cases? If it's an integer and if it's not?
If it's integer, then you'll have max a equal to min a, and
Right.
if it's not, so like the average will be somewhere like 0.5 or something maybe. So max a minus min a will be, or yeah, in that case it will be 1 because that's like the only case, right?
Yeah, kind of. Okay. That is right. I'll explain that in slightly more detail. So first thing you need to understand is, suppose let's take a simpler case, something like n equals 2. So suppose you have two buildings. This is of height 10 and this is of height 2. So what is the minimum thing you can accomplish out here? The minimum ugliness after doing any number of operations. First thing you need to see, can you make these both heights equal by any chance by, reducing this and increasing this? So in this case, you can do that. What you would do here is, you would remove 3 blocks from here and you would add them here. So ultimately what would happen is this 10 would reduce by, sorry, you would remove 4 blocks from here and you would add 4 blocks here. So this 10's height will become now 6. And the second block will also become 6. So in this case, they're equal and the ugliness is 0. Now suppose I make this 10 to be 11. Now can you do the same procedure and make them equal? You cannot make them equal this time. The reason is that the total number of blocks you have, that is 11 blocks plus 2 blocks is 13 blocks, which is an odd number. And you're asking me to divide them into equal parts, which cannot be done because it's an odd number, like by the definition of it. So what you could do out here is you can make the difference 1. You could go to 5. You could go to 6. and 7. You remove 4 blocks from this and you add 4 blocks here. So now suppose we take the general case, and in the general case, at any point of time, what we do is we find two buildings which have good amount of height difference, say more than one. What we could do is we could keep doing the same procedure and make them equal to either 1 or 0. If their sum is odd, then we could make the difference 1, and we could, or else we could make the difference exactly 0. What we could do is we could make these blocks exactly equal. Now you take the whole thing again, you keep doing this again and again. So what can happen is ultimately, if you can make all of them equal, if you can make all these equal, or the difference is maximum of 1. Because as in some places we are not able to make them completely equal, so we are getting a maximum height difference of 1. So it can either be a 0 or it can be a maximum difference of 1. Now we need to understand when can it be a 0 and when can it be a 1. So when can it be a 0? So if it's a 0, basically everything has same height. So if everything is same height, which means suppose say the height of one building is k and there are n buildings. So n into k is the total number of blocks used, and the total number of blocks is fixed, which you can find it. So n into k is equal to s. So we need to find whether k is existing or no. So if s is divisible by n, then k will exist. So if the total number of blocks is divisible by the number of buildings, so say total number of blocks is say 100 and number of buildings is say 5, then you could have 20 blocks in every building. But if this is not divisible, so in that case, what you could do is you could make all the buildings of equal height, and the max A is equal to the one height, and max B, min A is also equal to the same height, because everything is equal. So in that case, your ugliness would be 0. Or if this is not a proper multiple, if 5 say s is not divisible by n, then what you could do is you could divide s by n, the integer division. You can make all buildings of that height, but you still have few blocks left. Now what will be the blocks left? There'll be the remainder when s is divided by n. So the number of blocks left will be s modulo n. Now this will be less than n. So what I would do is I would add these s modulo n blocks over some 1 over the n buildings, or how many ever buildings I can add them. So what would be my situation is there'll be some buildings with height k, and there'll be some buildings with height k plus 1, because I have added one block now. So in either case, the difference is here 1. So we have seen the two cases where difference can be 0 and difference can be 1. So difference can be 0 if the sum is divisible by n, or else if it's not divisible, then difference is 1. So is the approach clear to everyone? If the approach is clear, we can move ahead to the code. If any doubts are there, you could ask them. Feel free to unmute and ask. Or anything, if you have any doubts, then you can put it. Yeah, Tanmay, you're right. It's either 1 or 0. So no doubts?
Sir, that S modulo n, you have to repeat that process, keep on or.
No, okay. So what happens is, suppose say your S is the total number of blocks is 100, okay? And I have say 6 buildings. So what I would do is, I would, so my N is 6. What I would do is, I can make all the 6 buildings of a height, which is a multiple of 6, just less than 6. Okay, so that will be 96 in this case, right? So I make 6 buildings like this with each of 16 height. Is this part clear first?
Yes, sir. But the remainder will be 4.
Yeah, now remainder is 4. Now actually I have 6 buildings out here. So what I do is, I'll make the 6 buildings. What I do is I have 4 blocks. Now 4 is less than 6. 4 should be less than 6 because it is the remainder when divided by 6. So what I'll do is I'll add one block here. I'll add one block here. I'll add one block here. And I'll add one block here. So over 4 buildings, I'm adding one block each. So I have already added 4 blocks. Now I've used all 100 blocks. Is this thing clear?
Yes, sir.
So ultimately what is happening is, now you see the difference. Now there are some things which are a proper multiple, like these are exactly 16 blocks. Now in some other things, you've added just one block. So if you take the maximum of this array, that will be this thing where you have just added one block, right?
Yes, sir.
Because the other ones are either equal to this or just less than this, or the minimum one will be the exact multiple, that is exactly 16 in this case.
Yes, sir.
So what will be the difference between them? There'll be one.
Yes, sir.
So if your n is if your sum is not divisible by n, so you could just add one block in the other in some of the buildings, and you could just use up the extra blocks there, and the difference would come out to be 1. So in that case, the difference would come out to be 1 if the s is not divisible by n. Yeah, was this point clear?
Yes, sir. Clear, sir.
Yeah, so we can just code that up.
Sir, but
So
where
yeah,
are we using this concept of greedy, sir? This is like.
yeah, okay. See, the thing is that suppose, okay, what are you trying to do in this case? Suppose you see some building is bigger than some other building. What you would do is you would try to make the bigger building smaller and smaller building bigger, right?
Sir, so that we minimize our.
We minimize the height difference. Yeah, exactly right. So, are you really caring about what else is happening in the world? Other buildings or anything else? You're just taking one block and putting it here so that the height difference are getting minimized, right?
Yes, sir.
So, that is exactly kind of a greedy thing. You're not really thinking about what is happening ahead or what is happening with the other buildings. You're just focusing on these two buildings and you're doing the operation. You're trying to make the height difference as less as possible.
Sir, clear, sir.
Now, also, other thing is that greedy is such a thing. Now, you don't actually need to know the term greedy to solve greedy problems. Like maybe you take this problem an example, you can solve this problem without even knowing what greedy is. So it's kind of that thing. Like it's a genuine doubt. Like where are we using greedy? So uh, yeah, you don't actually need to know what greedy is, what the definition of greedy is to solve greedy problems. Okay, but whenever you have more approaches, then you can be like, okay, greedy will not work here. So it'll be just an easy way to understand what this approach is.
So it
So
depends on the nature and complexity of problem, whether we
yeah,
are exactly, or it can be like a basic common sense like thing.
yeah. Most of the
Sir,
time, the greedy problems, whatever you solve, you will feel like, okay, this was just common sense where I use greedy. Kind of that thing. Okay, like you take this problem, for example, you're just minimizing the height difference. So yeah.
but in other cases, if it's more complex, means will have to know the exact.
Yeah, you cannot use greedy everywhere. That is true. That is absolutely true. You have to take care of some other things also.
Yes, sir, understood. Thank you.
Yeah. So we can just code this thing up. So what would be the thing? You have to test cases and you have to take the array as input. So I have taken the array already. So just take the array length as input. Now we need to find the sum. So we can take a sum variable. Okay. Just a minute. So if your sum is divisible by n, and you print 0, else you print 1. Okay, so we can run the sample. I'm putting the sample in input.txt and I'll see the output in output.txt. So it's 1, 1 and 0. Okay, so I think we messed up something. Or okay, CNA of I we are taking the input. CNA of n. Oh, the input part I messed up. The logic I think should remain the same. Yeah. So you can submit it. Now this also happened to be the first problem I solved on Code Forces. I took 10 minutes for this problem. So yeah. Okay, so I have another problem out here. We would come to that at the end because I would like to discuss another example out here. If you have time, we'll surely come out here. Anyway, I'll give you the slides and the code also will be given, so you can check that out. So yeah, this is the problem. We can start the slideshow now. So yeah, you can go through this problem, take maybe say around 4 to 5 minutes, around 56 or 57, we can discuss it. Okay, if this is covering the thing, yeah. If you have doubt in the problem statement, then you could ask, or anything, any doubt in the previous thing still now. After every point of time, the size of the array is changing. Say initially the size was 5, and you remove an element, meaning you permanently remove it. So the size of the array is now 4. And the first element is also something else now.
So here, like, you can keep the array and like the count of the number of times which it had this operation has to be done.
Yeah, that is okay.
So like
What
we
do you
can
mean
take
by
two,
count of the number of times the operation
like
is supposed to?
if the first time when we are doing it, so the operation, like we are about to do, we had to do the operation like k times. So we'll keep
Yeah.
like that thing as k. Then we'll go to like two possibilities. One is like we remove the first element, and the second is we remove the last one.
Okay.
And then like in each case we'll obtain the array which we obtained, like from after removing the first element, the array will be of one type. After removing the last element, the array will be of one type. And
Okay.
then perform the same thing on these ones, except that for each one will become like k minus 1.
Okay. So you're so for every step you're saying that there are two possibilities. You can either remove from the first or last, right?
Yes.
So what would be the time complexity of this code? You're right. You're absolutely right. That's a brute force approach. You're trying everything. What would be the time complexity? Could you just think how many iterations you would require to do this? At every step, you're checking two possibilities, right? And for the every
So it's like 2
possibility,
power n.
2 power k. So what do you think? Is this a good complexity or a bad complexity?
Obviously, like not that great.
Yeah, 2 power k. So 2 power k is actually first thing is that you always try to keep your thing in polynomial time, then you go to exponential time. So what you told, your approach is absolutely correct. There's nothing wrong in that, but we can do a lot better by that thing. We can do a lot better by thinking of something else. Maybe we can use greedy because this session is about greedy. Okay, so is the problem statement clear first to everyone? Maybe I could just show a sample out here. I'll go over the slideshow itself. Maybe suppose you take this array and you perform these operations. Okay, so suppose this array and k equals 3. Forget about the code part. Just see the array and what do you think can be the maximum sum obtained by this? First thing, is the question clear? Yeah, I forgot to ask that. Is the question clear to
Yeah.
everyone? Yeah, okay. So k equals 3, so you can actually dry run that thing. And what can be the maximum sum that you can obtain by removing either the first element or the last element. So what happens here is, suppose you remove 6. Can you guys see my cursor? Okay, the cursor is not visible. Okay.
Now it's visible, yeah.
Okay, the cursor is visible. So suppose you guys remove 6. So the new array now is this array, 5 to 10. Okay. So, okay, I've shown the solution out here, but yeah, I would still like to ask, what do you think will be the maximum sum you can obtain after removing 3 elements?
In this case, it will be the last element and the first two.
Yeah,
So
that's right. Last 2 elements. So you remove the last element, then you remove the first element. Now the first element is not changed. It is 5. So these are the 3 removed elements. The sum is 21. This is also the maximum sum because, anyway, you're removing the greatest 3 elements in the array. So this has to be the maximum sum because you're removing the maximum elements. So first thing is the sample clear to everyone.
yes.
Okay. So let us try to solve this problem greedily. What I'm saying is, for k steps, if the first element is greater than the last element, then I'll remove the first element. Why I would want to do that? Because I want to maximize the sum of the removed elements. Okay, so I would remove the first element. Else, if the first element is not greater, then I would remove the last element. Okay, so this is my greedy approach. We'll try to apply this on the sample as well. So this is our sample. My last is 10. My first is 6. My last is greater than first. So I remove last. Now my last has changed. Now my last is 2. My first is 6. So I remove the first element because the first is greater than last. Now my first has changed. Now my first is 5 and last is 2. So I remove first equals 5. So my sum of removed numbers is 10 plus 6 plus 5. That is 21. So we can go ahead with the greedy approach, right? So any of you have any doubts in this approach, or you feel this approach is wrong? Anything? It's not necessary that whatever I say is right. It might be wrong also. If you feel this approach is wrong, or if you have any doubts in this, then you could ask them. First thing, have you understood the approach? The approach is basically saying what you're supposed to do is you're supposed to remove, you're supposed to maximize the, okay, I've shown the thing, but yeah. You're supposed to maximize the sum of the removed elements. So what I'm saying is, at every point of time, I'll just remove the greatest element. I have 2 choices of removing. Either I can remove the first element or the last element. So whatever is greater among them, I will remove that, such that, whatever the elements I'm removing, they are greater elements. So I'll get the maximum sum. This is my approach. So this is basically greedy approach, because at every point of time, you're seeing which is greater and you're removing it. This decently works on our sample as well. So is this approach right?
There are obviously going to be like a few outlying cases wherein this
Okay.
approach is not going to work. But
Okay. Why do you think so? And maybe you could say, give a small case like that. Anything, maybe say 2, 3 elements also, that's fine. K equals 1 or K equals 2 also.
When a smaller element is in the end, and it is backed by very large elements which are continuously there.
Okay.
And,
So this works on a sample. So some of you might assume that this thing is right, but just because it works on one case does not mean it's right. So does greedy work always, as one of our friends pointed out earlier in this session also? No, it need not work always. You take this example and K equals 2. Now, forget about greedy, forget about all coding and all. Just logically, what do you think will be the maximum 2 elements you can remove? I have to remove 2 elements, one from using the same thing. Either I can remove one first element from front or back, and then I do the same thing. So what is the maximum sum I can remove?
11, 6 plus 5.
Okay, can I do better?
And
There's
obviously
some,
you can get to the 100, but then for that you have to remove the one.
yeah. I forget about the approach. You can just tell logically what do you think will be the maximum number? You can just
106.
do 2 operations. Yeah, sorry.
No, 101 was like remove the first 1 and 100. So
First and
101.
100. Yeah. So first and 100 is what would be it logically, but our greedy approach says last is 6 and first is 1. So last is greater than first. So you remove last. Last is 5 and first is 1. Because now the 6 is removed. So the array is now 100, 3, 4, 5. So now my last is 5 and my first is 1. So you remove last equals 5. The sum of removed elements is 100. But by inspection, you can see that the numbers, just as one of our friends said, that you can just remove the first two elements and the sum of the removed elements would be 101. So our greedy approach is actually not right out here. So just to illustrate this point again, greedy does not work always. Okay, it might be the case that you have to apply something else. It need not be always greedy. Sometimes you might have to go by the brute force approach or maybe think of something else. So we will see how to solve this problem. But firstly, has everybody understood what greedy approach I was talking about and why it is wrong? Any doubts out here? Yeah, Jay Gautam, you were right. So anybody has any doubt in the approach I discussed, which was a wrong approach, but I would still want you to know it because this is a very probably say something like a smaller problem, but when you get a bigger problem, you should be able to think whether greedy really works on it or no. So uh, a greedy approach, and to see why the greedy does not work, you take a case. So is everything clear till here? If everything is clear till here,
Yes, sir.
yeah, yeah, okay, right. So let us try to solve this problem. So first thing, moving k elements, we have a subarray of length n minus k. Now what do I mean by subarray? So a subarray is, okay, I would probably like to draw here and then we can come to the slides again. So this is my array, say k elements. Okay, and I'm n elements and I'm removing some k elements. Suppose I remove some from back, some from front, whatever might be the case. Now the remaining elements is n minus k. Is this fine? After removing k elements from the array, the number of elements remaining are n minus k. And that is a contiguous subarray. Basically, they are all consecutive elements because at every point of time, I can either remove the first or the last. I cannot remove somewhere in the middle. So whatever elements remaining in the array, there will be all consecutive elements. A consecutive elements thing is called a subarray, just a technical term. So is this thing fine first? Then we can move ahead to the next step. That there will be n minus k elements remaining. Or any doubts, you can put them in the chat also if you have any doubts. Yeah, okay, so I take that as no doubts. So we have n minus k elements remaining. So what we are supposed to do is, we are supposed to maximize the sum of the removed elements. So we can think of it in this way, that we are supposed to minimize the sum of the remaining elements. Right? Because the total sum is constant, because the array given initially is fixed. You're not adding any number to the array or something like that. So the sum of the array is fixed initially. So the sum of the removed elements, suppose you're removing say k elements, so this sk plus the sum of the remaining elements, say s of remaining, is fixed, is some constant c. Okay. So you're maximizing this sk. So you're supposed to minimize the srem, the remaining elements. So you're supposed to minimize this subarray sum of length n minus k. Is this thing clear? How our initial problem was something else, but we made it into a different problem. So I think I've written that in the slides also. That after removing k elements, we'll have a sum of subarray of length n minus k. So sum of removed elements plus sum of remaining subarray is equal to sum of all elements, which is a constant because the array is given initially. So we have to maximize this thing by the question, because the question was saying that you have to maximize the sum of the removed elements. So you have to minimize the sum of the remaining subarray. Okay, so is everything clear till here? If everything is clear till here, we can move ahead to how we can minimize. So how we can achieve our goal, which is to find a subarray of with minimum sum. Is everything clear till here or any doubts? Feel free to unmute or ask in the chat also. Any doubts still here? Okay, so no doubts, or do I need to explain anything again? If I need to explain anything again also, feel free to tell it.
Clear, sir.
Yeah, okay, cool. So now we're supposed to find a subarray of length n minus k. Say this n minus k is some L. Find a subarray of length L with minimum sum. Does anybody has any idea to do this question? Given an array, so what is happening is, okay, how do I, yeah. So given an array, I have to find a subarray of a fixed length. So say the array is of size 10. I have to find subarray of size 3. Basically, I have to find 3 consecutive elements with the maximum sum. So how can I do this thing? Does anybody have any idea? It might not be efficient. It might be O of n square, O of n cube, or O of 2 power n, anything. Does anybody have any idea to do this thing?
Harsh,
Could you repeat? Your voice wasn't clear.
So like we can keep an index or some sort of variable for like the last element of like which number is exactly the last element of this minimum sum of subarray.
Okay.
And then like we initially choose that the first say n minus k elements are in this minimum sum subarray.
Okay.
And then we add like we basically put up their sum and
Okay. So initially you're fixing one element, which will be the last element of your subarray. How are you fixing that element? Like which element are you going to fix?
so the n minus kth element at
Okay,
this
n minus kth element, right? So you're taking this, the initial subarray, like from 1 to n minus k, right?
yeah.
Yeah, okay. That is your one subarray. So after that, what will you do?
So then like I will try to subtract like, the first element and add the last. So first calculate the sum of this subarray, which we have the initial one.
So you'll add this and you'll subtract this, right?
So first we'll calculate the initial sum, then we'll add the the other one, the new one, and subtract this first one, and check
Yeah,
if this new sum is lesser than the old sum.
okay.
Accordingly, we'll shift it. If it's
You'll
not, then
keep shifting it. Yeah. So yeah, that is one of the approaches to solve this problem. So we can discuss that thing. What our friend was saying is that suppose we'll take something with values, values make us understand things better. Suppose you have an array, or else I'll take array values also. Suppose I take something like 3, 6, 8, 1, 10, and 4 or 5, something like this. And my L equals 3, or say n minus k equals 3. Okay. So I want to find the subarray of maximum length of L. So what I would do is I would find this sum. Okay. The first L element sum. Okay, that I can do. I can go till I equals 0 to I equals L minus 1. I can find that sum. So let this be S. Now, when I go to the next subarray, what will the next subarray be? The next subarray would be you start from 6 and you go till 1. So what you're doing here is, suppose you have your initial subarray. Let this be your initial subarray. You're removing this last element. Okay. And then you're adding this one more element. Okay. You keep doing this again and again. So what is happening here is I'll again repeat my point if I was unclear the first time. You take the initial subarray of size L. Okay, now L is given. The L is equal to n minus k. K is given, n is given. So L is fixed. So say L equals 3 and this is our array. So you get this thing. Now this is a valid subarray, so you find the sum. Now what you do is, what will be the next subarray? The next subarray would be, you remove this element, you remove the first element and you add the next element. So now my subarray is 6, 8 and 1. Now I can again do the same thing. What I would do is, now in my new subarray, my element is now, first element is 6 and my next element is now 10. So I would remove this 10 and I would make it 8, 1, 10. So by this way, you would get all your subarrays. And what you could do is, for finding the sum, what you could do is you can find the sum initially of this. Then since you're subtracting this element from your subarray, you could subtract it from the sum as well, because the middle elements are anyway not changing. Suppose 3, 6 and 8 is there. 6 and 8 are being fixed. Only the 3 is removed and 1 is being added. So what you could do in your sum is, you could remove this sum, the first element, and you could add the next element. You would get the sum of your new subarray and you could take the maximum with the original sum. And you could keep doing this again and again for all subarrays to get the maximum subarray sum. Now, was this thing clear? Or do I need to repeat any part of this? If I need to repeat, yeah, I'll be happy to do that. Any doubts in the chat also, I would see that. Yeah. Is this thing clear, or am I going too fast, or maybe not explaining
Sir,
something
we can
properly?
take initially we can take any 3.
Okay.
So
Any
like
3 elements.
yeah,
Are you asking a doubt in this, or are you
asking sir,
suggesting?
we can take any 3 and we can repeat this process. Doesn't matter only the first 3 are.
Yeah, okay. What would happen is, you mean, yeah, you can take any contiguous subarray, but then you would also have to go back also, you have to go front also, right? Suppose,
Okay.
you got my point.
It will make more complicated.
So if you're suppose taking 110.4, what you told is also absolutely right. You take 110.4, you keep going front the same way. Suppose there are more elements out here. You keep going front the same way, or you keep going back the same way. What does back mean? You remove the last element and you add the first element. So that is also right, but writing the code will be slightly complicated because you're going both front and back out here. So when you're taking only the first element, you're going only front, or else you can take only the last subarray also, then you'll go only back. So uh, what you told is right, but this will be an easier implementation. So yeah, any more doubts in this thing? Or anything I need to explain again? Okay, so we can move ahead to implementing this by code. The code is also uh, decently easy. Now this is actually not a online just problem or only any online platform. You
Sir,
just need,
when do
yeah,
we
yeah,
know that the maximum sum is reached? Like
yeah, yeah. At every point of time, we will be taking the maximum value. Like suppose our sum initially is S1. After removing
maximum
this,
possible.
yeah, at every point of time, suppose my initial sum is S1. Now what I would do is, I would do S1 equals S1 minus 3. S1 minus equals 3. Okay, so I basically remove the first element and I'll do S1 plus equals 1. Right, now I've got my new subarray. Now what I would do is, I would again, I would take this maximum. What I would do is, I would write something like, suppose my maximum is M. I would write M is equal to maximum of M comma sum, M comma S1. What this would do is, suppose my M is storing basically the maximum subarray sum. So suppose my maximum subarray sum is something else till now. So it will remain the same. Now suppose my S1 is greater than the maximum subarray sum. So what would happen is, now my M becomes maximum of these both, which is S1. So M would become the new subarray sum, the new maximum subarray sum. And we would do that for each element after we take each subarray. Did you get this thing? I would write it by code also now, but yeah. Did you get the concept how we are finding the
Clear,
maximum?
sir. Thank you, sir.
Yeah, fine. We can just implement this by code. So say we take an array. We'll take an array as input. Then What you could do is we could maintain a sum variable which stores the sum. And what our SI initially, what is it initialized to? We are finding the first L elements sum, right? So we'll take the L also as input, which will be maximum, the subarray of size what? What I would do is my initial sum would be the sum of the first L elements. Okay, so 0 to L minus 1, sorry, 0 to L I need to go. So 0 to L I go, I take the sum of the first L elements. Okay, so this is my initial sum. So now what I do is I create a max variable or say M variable, which is storing the maximum sum. So initially it is equal, initialized to sum. So what I do is now I need to iterate to find all the subarrays. What I do is I go from I equals n minus L, because there will be n minus L subarrays of size L, or sorry, it'll be what? N minus L plus 1 actually. Yeah, there'll be n minus L plus 1 subarrays. So for each of them, I take it once. Just a minute. This number would be okay. So what we could do is our present position plus 1 and yeah. Okay, so we have taken our sum till L elements. So we are now trying to find the sum of the L plus 1th element, and we need to remove the first element. So what I could do is I can start my thing from L itself. I go I less than n, I plus plus. What I do is I do sum minus equals a of I minus L. Now what this is doing is that it's removing the first element. Because suppose now initially if you see L is equal to I is equal to L. So it's removing the first element, sum minus equals a of 0. Now when I move it to the next subarray, suppose my I equals L plus 1 now. And my subarray is also changed. Now when I equals L plus 1, this has become clumsy. So I'll just write something else here. 3, 6, 8, 10, 1, 5. So initially my subarray is this. So my I minus L is pointing to this. Now when I change my subarray, my I is changed now. So my I minus L is pointing to this. So I'm removing the first element. So sum is equal to sum minus equals is basically sum equals sum minus A of I minus L. And what I add is sum A of I. I of I in the sense, now 3, 6, 8 is your suppose initial subarray. I add the next element and I subtract the element which is L elements before this, because I don't want this to be included. So, okay. And at every point of time, I take my max to find the sum and I can just print the max. So this should be the code for this thing. Now, in our case, the original problem was that you have to find a subarray of length n minus k. And here, so you put your L equals n minus k and you would find this value of maximum subarray sum. Now, this would be the answer to this problem. Okay, so firstly, initially, are there any doubts in the code? Are these two statements clear? I fumbled slightly while writing those, so just wanted to ask, are these two statements clear? Why, which element am I subtracting and which element am I adding? Any doubts you can ask, or you can write it in the chat also. I would see the chat. Okay, so there are no more messages in the chat. Yeah. Any doubts?
One small doubt though, like suppose if
Yeah.
there's like the k number of elements, say we have an array of like 9 elements and we have to find the minimum sum subarray of like 3.
Yeah.
So
Right.
then if we if we assume that the first 3 elements are like minimum, and then we have like a max of 3 elements in between the next 3, and then the other last 3 are also their minimum sum is much lesser than the first ones.
Sorry. I lost you somewhere in the middle. You're finding the suppose n equals 3 and k equals say n equals 9 and k equals 3. You take the first 3 elements. Their sum is you take that sum, then what do you do?
Then like the next three elements, they're obviously if we add them, their sum is like bigger, so it becomes bigger, so we ignore them. But then on the other side, we'll have like the actual minimum sum subarray.
Okay. So actually, I'm supposed to take minimum out here. Always we are discussing about minimum. Sorry about the, yeah, minimum subarray. So what is happening by this is you're actually finding all the subarrays. Like you see, you
Okay.
take an array. This code is basically giving you all the subarrays. I'll just give you an example how this code is working. Just for a small case, we can try run and we can probably end it then. Suppose I take 3, 6, 8, 10, 1, 4. My initial is this. Is this thing clear? My initial is 0 to
Yeah.
L minus 1. Now what I do is I remove this element and I add this element. So my
Yeah.
now new sum is this. Sorry. New sum is this. Now I do the same thing again. I remove 6 and okay, this was supposed to be a 10. I add this. Okay, so
Yeah.
this is my second iteration. Now my new subarray is what? 8, 10, 1.
8, 10, 1.
Now I do the same thing. Now 8 is my new initial element. I remove this and I add the next element. I add 4. Right. So now my new subarray is what? 10, 1, 4.
1, 4.
So you see, in this process, the loop we are iterating, we have actually got all the subarrays. We are not like skipping or we
Okay.
are optimizing it anywhere. So the
Okay.
first 3 are getting, then the next 3, then the next 3, the next 3, and so on. And since I'm running this loop till n, so basically I'm not optimizing anything anywhere. I'm finding all the subarrays and I'm finding the minimum sum.
Understood.
Okay, so is that clear? Like you'll not
Yeah,
be
clear.
missing anything anywhere. Yeah, good, right.
Understood.
Yeah. So anybody else has any doubts, you can feel free to post them. Don't think that, this doubt is very dumb or some easy doubt. Why shall I ask? Nothing like that. We are here to clear your doubts only. So yeah, any doubt in this approach, how we are trying to do this approach or how we're getting all the subarrays? Okay. So no doubts or any doubts, you can put them in the chat also, which is fine. Okay. So yeah. So I have one more problem to discuss, but I think it's already 4:30. I won't keep you here for more time. I know many of you are already cursing me in your mind to end the session. So we can end the session out here. This one problem, you can you can actually try this problem on your own. I would still give the code. I would solve it like now, and I will paste the code link out here. The code link would basically be my submission. Like say in this case, this submission ID where you can just see the code. Uh, but I would highly recommend you to write the code on your own, and then only you'll understand what errors can be done or what something, because seeing someone write code and writing the code on your own is a very different thing. So yeah, this last case, this solution we discussed is not a greedy solution, because we're actually caring about we're not really removing elements. This would be a greedy approach without really caring about anything else. But we are checking the middle part for all the elements. So this is actually not a greedy approach. So I just want to take this example to show that every problem is not greedy. You have to think. You think by a greedy approach. If you think your greedy approach may not work always, then you have to go by another approach. Okay, so yeah, that's it from my side in the session. And thank you for your attention. I know it's not easy to be in a lecture for 1 hour or 1.5 hours, but hopefully many of you were patient out during that time. Thank you for that. And any doubts in any of the thing which I discussed today or the earlier part also? If there are
Sir,
no
in that
doubts, yeah, yeah.
previous situation, why are we not like using sorting, sir?
Which one? Which question?
In that previous question, last
Okay.
question you.
Okay, last question. You're
Why?
asking why are we not using sorting? Okay,
Yes.
so what will happen by sorting is basically you will be changing the order of the elements. Say you take this case itself. What would happen is you would change the order of elements. You would be like 1 comes first, 3 comes first, 4, 5, 6. And in our question, actually we cannot strictly change the order. We are not allowed to change the order at all, because if we change the order of the array, then the first element will be different and last element will be different. It will not be what it was in the initial array, right? Okay, I would repeat my point again. Suppose you want to calculate the sub array sum. Now sub array sum is basically consecutive elements. Okay, there'll be consecutive elements. So suppose I take this example only. I'll take this example. Just a minute. 3, 6, 10, 8. This is my example. Now suppose I take this subarray. Now when I sort the elements, actually, I will not have this subarray at all.
Okay, the order will totally vary.
Order will change. Now you see 1, 3, 4, 6, 10, 1. Sorry, 10. Now you see the subarray starting with 3 is 3, 4, 6. But in the initial array, 3, 4, 6 was never there. So whenever in questions you see that, you're removing the first element or last element, basically when things are dependent on the position, you cannot sort, because when you're sorting, what will happen is you'll change the position of the elements. Okay. Is this thing clear, whatever I told, or you want me to explain it again?
So another thing is that need not be the any like, suppose if you want to find some other intermediate value between the maximum possible sum minimum possible sum, we can work this. You can use this method, but while sorting won't work in that case. We can say like that also, right?
Yeah.
Where in case of max of n comma sum, we can replace it by some. We not use that max of n comma sum. We can say greater than some limit k, like that we can use. It was an if else loop, if else and condition.
You would write if m is less than sum, then m is equal to sum, something like that.
Yes, sir. Where
Yeah,
the m
that was
won't be the maximum or minimum, but some value which.
Okay, if you want to get say number of subarrays which some value lesser than some value, you can do that.
Yes,
Also,
sir.
saying something like if sum is less than k, then you would k is some value given, you would want to print that thing or something like that. That's what you're saying?
In a given array, suppose if you want to find the, like, suppose there are like 10 elements, and we have to find those 4 elements which are greater than whose sum is greater than some limit, say.
Okay. Yeah, absolutely, you can do that. That is fine. That is right. That is, this prompt can be extended to that also. What you could do is, if sum is greater than that whatever number is given, then you could print those 4 elements. You could print from, or you could just write this thing has been found, something like that you're trying to say, right?
Yeah, something like that. We can use that. We use the same logic in that case also.
Yeah, you can do that.
Yeah.
You can. That's
Okay,
right.
thank you, sir. Yes, sir.
Yeah.
Sir,
Yeah.
if even in this case of like this sorting, why can't we suppose if we are sorting and then even though the order is changed, with the initially unsorted list, we can copy it in another like another array, and why can't we compare it and rechange the order finally?
Okay, so when you're what do you want to do after sorting? Like, what is the use of sorting then? If you're like storing the elements in another array again, like you are saying that you would sort these elements and you would store this in some other array, right? Suppose b of I, right? This is what you want to do. Then what would you do for finding the max reason?
Yeah, like the initially unsorted thing we can copy in one another array, and
Okay. Yeah.
and then this one another this one we can sort, while we will find the first initially the least number of those all those least values, we can then extract them, and then we can compare them with the initial case, initially unsorted one.
Okay, but one thing you need to see is that these least values actually need not be consecutive in your new array.
Okay, fine.
Like if you say 1, 3, 4, you see in 1, 3, 4 might not be consecutive. Like you see 3 is somewhere, 1 is somewhere, 4 is somewhere. Like if you are allowed to, say you are allowed to take any 3 elements, whatever you're telling is right. You sort them and you take the minimum 3 elements. That was very similar to the first question that we discussed, the first starter question. There you have to put n boxes, n items, irrespective of, it's not like first, last or anything. So you sort them and you take the n maximum items. But here you're supposed to add only those items which are consecutive to each other. They might be, some might be big, some might be small. That might be the case.
Okay, clear, sir. Thank you, sir.
Yeah. Yeah. So any more doubts? In any of the things we have discussed? Okay. So I take that as no doubts. And okay, so there's a